Hello, everyone. I'm going to go ahead and share my screen first. Okay, let's see. Let me make sure I'm recording first also. Okay. Okay, so this week we're going to be covering exercise 2 in your lab manual. It is called the metric system and basic microscopy. Before I begin, I just wanted to go over some announcements. So first, I'm going to put these videos up by activity. Because that way, if I notice I make a mistake in a specific activity or I forgot information, I just have to redo the video for that activity instead of redoing the whole video. It will be much easier on my part to do that. So I hope you guys can follow through with this new format. If you need any help or have any questions, just please let me know. Also, I wanted to go over your guys' submissions, your worksheet submissions. So I'm sorry for the confusion. I should have explained this prior to last week, but I do allow 3 submissions for your lab worksheets. However, that does not mean that you guys can correct the mistakes and then resubmit your worksheet for a better grade. The reason I allow the 3 submissions is in case you uploaded a blank document, you can go ahead and upload the proper document. Or if there was some formatting issue with the document you uploaded, I will let you know, or you could even notice it on your own and then go ahead and upload the properly formatted document to the assignment. Like I said, it's just going to be really, well, I mentioned to a few of you, it would be really difficult for me to grade 3 worksheets per student. I do work full time and I also am a student at UCR. So my time is very limited. I will try to give you guys feedback on your worksheets. So I hope you noticed that I gave comments. I haven't finished grading, but I try to log on every night or every few nights and grade whoever's submitted their work. And I try to give feedback so that you guys can use that information for your quiz. I do suggest doing the worksheet before the quiz so that way you kind of have an idea of what's going to be asked on the quiz. It will be to your own benefit. Okay, so today we're going to start with exercise 2, the metric system and basic microscopy. And the first thing, so these are just our learning objectives. So first we're going to learn how to use scientific notation to represent large or small numbers. Then we're going to learn to use the metric system and convert between common prefixes. We're also going to identify the components of the light microscope and understand how the following terms change as you move from the lowest to the highest power objective. So you're going to learn about resolving power, field of view, and working distance. So let me go ahead and put on a pointer laser. There we go. So in your first activity, you are going to be using scientific notation. And the reason we use scientific notation is because many scientists tend to work with very large numbers or very small ones. So I just listed 2 scenarios here. So if you were talking about the mass of an electron, this would be an extremely small value. It's even so small that it's kind of hard to comprehend. And for example, a large value would be how many cells are in the human body. As you can imagine, this is an extremely large value, also pretty hard to comprehend if we were to list every single 0 in this value. So we work with scientific notation when we work with extremely small or extremely large values. And this is a great tool to essentially abbreviate these numbers. So it's less, I guess, daunting to look at. They're much easier to work with. They're easier to visualize and comprehend the values. So for example, if you have a value that's 7 times 10 to the 5th power and a value that's 7 times 10 to the 22nd power, it's easy to comprehend that 7 times 10 to the 22nd power is a much greater value than 7 times 10 to the 5th power. So it's easier to communicate, so both verbally and written. Imagine trying to communicate in a presentation or even in a manuscript a very large value, so the size of the mass of an electron or something. Having to write that out over and over and over again would be very difficult. And honestly, sometimes those extremely large values, you don't even know how to articulate them when there's that many zeros. Like after a million, I don't know how to articulate values larger than that. It's also great to avoid confusion and to maintain accuracy. So these are some benefits of the scientific notation. And I wish this was popping up one at a time, but I think it's easier for you guys at home when everything comes up at once on your guys' PDFs. So here we're going to start off with our original number or expanded number, which is 7,040. And then if we were to write that in scientific notation, this is how it would be written. It would be 7.04 times 10 to the third power. So essentially here, you want to have one digit before the decimal point. So here you have your 7. So pretend your decimal point is here where my cursor is at. We have to move this decimal point 1, 2, 3 times to the left. So we get 7.04 times 10 to the third power. We move that decimal point 3 times to the left. So all remaining significant digits will follow the decimal point. So here your 0 and your 4 will follow your decimal point. And this number should then be multiplied by the appropriate factor of 10. So the appropriate factor of 10 in this example would be 10 to the third power. So here it is also broken down for you. Like I said, you will only have one integer before the decimal point. This is going to be a value from 1 to 9. All other values or significant values will be after the decimal point. You're going to times this by 10 to the appropriate exponent. In our example, it was 3. This exponent can be either positive or negative, and that depends on your original number. So if the original number is greater than 1, then the exponent on the factor of 10 will be positive. If the original number is smaller than 1, the exponent on the factor of 10 will be negative. And we will go over examples of both of these. Okay, so here I give an example of working with an extremely large number. This is Avogadro's number, and it's used in chemistry. So if you're a chemist and you're working with this number in a manuscript, as you can imagine, it would be very difficult to write this number out every single time in your manuscript, and it would be very difficult to articulate this value in a presentation. So it's easier if we write this using scientific notation. So here you have a 6 followed by 23 digits. So in order to write this out using scientific notation, we would have to see how far we have to move our decimal point over. So we would go, we would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So now we would have that one significant value before the decimal point, and it would be written as 6.022 times 10 to the 23rd power. So this really is just a good example to illustrate why we need to utilize scientific notation. This is an example from your book. So if you wanted to represent 20,045 in scientific notation, you would need to insert the decimal point after the first non-zero whole number digit of the original number. So it would be 2.0045. You have to determine the exponent on the power of 10 that is appropriate by counting the number of spaces the decimal point has moved. So we have moved our decimal point 1, 2, 3, 4 times to the left. In this case, the decimal point has moved 4 spaces. The exponent is positive because the original number is greater than 1. So here we have to move this decimal point 4 times to the left. So 1, 2, 3, 4. So we end up with 2.0045. And to write this in scientific notation, we would write 2.0045 times 10 to the fourth power. So far we have been discussing how scientists could use scientific notation when working with large numbers. But many scientists also work with extremely small values. So an example would be the radius of a hydrogen atom. So let's say you had to work with this number here. This is not a very easy number to deal with or to articulate in a presentation or to write. So it would be easier to represent this number using scientific notation. And we do this by using powers of tens. So this is now using an original number that is less than 1. So here we're going to have to move our decimal point to the right instead of the left. So we have to move it over 2 times. So we can do 2 times 10 to the negative 2. And this is actually written in your guys' lab manual pretty nicely so you guys could comprehend what this actually means. So 10 to the 0 power is 1. 10 to the first power is 10. 10 to the second power is 10 times 10, which is 100. 10 to the third is 1,000, and so forth. And then it also shows it in to the negative power. So 10 to the 0 would be 1. 10 to the negative 1 is 1 over 10, which is 0.1. 10 to the negative 2 is 1 over 100, which is 0.01, and so forth. So there are these examples in your lab notebook that I want you to complete on your own. I did give you the first 2 just because we are not in class and I want to make sure you guys really comprehend this concept. But go ahead and do these 3 examples. Hopefully you got the same thing on the first 2 and then hopefully you are able to complete the last one on your own. So I believe that would conclude scientific notation. So I will post another video showing us how to use the metric system.